Now we're going through a question, another question to do with two of the four colligative properties. Remember, we've been talking about these colligative properties, and we know that it's nothing complicated. It's the most of it, the things that we've been doing already. And what it is we know that these properties are the properties that are affected by you changing the concentration of a solid in your solution. So we have water, which is going to be our solvent. Now we are adding something, could be sugar, could be salt, whatever it is, anything that's not water that can dissolve in water. We're adding it into the water. And what we know is that four things will be affected. And these four things are number one, the boiling point, number two, the freezing point, number three, the vapor pressure, and then number four is the osmotic pressure. So these four things will be affected. Now, we are looking at two that are very closely related and in common sense. Only that one goes up, one goes down. And that is the freezing point, which when we start adding more solid, the freezing point goes down. And then boiling point, when we add impurities, when we add things to our solution, when we add more solute, when we add more solute, the boiling point goes up. So the boiling point of water with salt is higher than the boiling point of pure water. Right, now, all we're doing is we're doing a calculation. Now, what are the formulas that we need to know for this boiling point elevation and freezing point depression so we can do the question? The formula is that it comes from the fact that the change, remember, when we say boiling point elevation, we are just saying the increase in boiling point. Freezing point depression, we are just saying the decrease in boiling point, in freezing point, right? Okay, now remember, freezing is the same as melting, only that we are going in the opposite direction. When we are melting, we are going up. When we're freezing, we are going down. We are freezing it. We're turning it to solid. So now what we are saying is this. This is a change in temperature. The elevation of your boiling point, you're increasing temperature. The depression of your freezing point, you're decreasing. And we say the change in temperature is directly proportional to small m. Now, you must understand that in this topic of solutions, small m represents concentration. And this concentration is in molars instead of is in molality. So we talk about molars, is in molars, which is related to molality. And molars, remember that this is an important unit. When we say 1 mole, this is equal to what we say 1 mole of the solid, 1 mole of the solid divided by 1 kg of the solvent. So solvent is no longer liters. Remember, molars, capital M, was 1 mole per liter. Molars is 1 mole per kg. Per kg. So what we say is, you must understand that we know that the change in temperature is related to concentration, but the concentration is in molars, small m, not a big M, but a small m now. And this leads us to the formula to say that the change in temperature is equal to K, some constant, times m. Remember that we always, when we remove this fish and we put an equal sign, we multiply the right hand side, this side, we put a K there. So it's a constant. So it's now the change in temperature is equal to K times m. Now, this is the same for both boiling and for freezing point. So for boiling point elevation, we are saying what is the change in temperature. When we say for boiling, we'll be saying the change in temperature, then we put a small b for boiling. That means the boiling point elevation. This is equal to Km again. Remember, K is just a constant multiplying the molality, the concentration in molar. So it's Kb, which is the constant, the boiling constant of that liquid multiplied by the concentration in molars. And then another one which we're going to need is the change in temperature is just going to be, here what we do, we say the change in temperature, say for boiling, this is going to be the temperature of the solvent, okay, minus that of the, no, that of the solid minus that of the solvent, I'm sorry. It's always that of the solution, not solute, what am I saying? Minus that of the solvent. minus that of the solvent on its own. Then this leads to the boiling point elevation. We will use these two formulas. I'm going to show you because this second one, we will use it mostly, this second one, to say of the solution with the solid minus that of the solvent alone, you will get the boiling point elevation. It's common sense. We're saying we are increasing the boiling point of water. So if we want to know how much we have increased, we see the boiling point of water with salt, we subtract the boiling point of water without salt, then we will know how much we have increased the boiling point. So that means the boiling point of water as a solution, that means with salt, minus water alone. Then we will know how much adding salt will increase the boiling point by. Great. And remember that your temperature is going to be in degrees Celsius. And then your concentration is going to be in molars, right? All right. Now that will affect your K because your K is going to be in degrees Celsius per molars. All right. Now for freezing is the same thing. We're now just saying the change in temperature. This is now freezing point depression. Change in temperature in the freezing temperature. That's the freezing point depression. The reason depression means it goes down. This is just equal to the constant, freezing constant, times the concentration in molars, Km. So remember that delta T is Km. Remember that. Don't ever forget it. For freezing, you put delta Tf is Kf times the molars. Okay, these don't change whether it's freezing or boiling. Then now we're going to say that, again, the freezing point depression is just going to be the temperature. Now look at what it does for freezing point depression. What we know is that the solvent alone is going to have higher temperature than the solution because adding something reduces the freezing point. So we will say now solvent, because it has higher, minus the freezing point temperature of the solution. Okay, of the solution. And this leads to the end of the formulas that we are going to use. Now let's go and attack a question and let's see how it goes. Here's the question. It says, let me do it in the next video. Bye for now.